Today is August 26th, 2026. This research overview is AI-generated, based on a partial daily collection, and requires human review before its claims are reused. 26 paper analyses are included. The clearest theme is agent infrastructure, systems that repair their own external harnesses, preserve working state, coordinate specialists, learn from verified execution, and contain failures. We will also examine predictive robot control, dense on-policy supervision, multimodal data, and several useful negative results.
Start with durable agent repair. AutoSadler diagnoses failed traces and patches, prompts, tools, or middleware, then tests changes on held-out tasks. Its measured Gaia 2 pass rate rose from 53.0 to 62.0%. On SWE Bench Pro, the table supports an 8.4-point gain, despite a conflicting 9.6-point claim elsewhere in the paper. Recurris similarly uses traces, but couples persistent procedural memory with verified working state. It improved 35 of 37 completed model and benchmark pairs, although several individual differences remain statistically unresolved.
The Recurris component results matter more than that broad count. On a retail benchmark, working memory alone added 23.9 points, while experiential memory alone added only 2.0 points, with an interval that included 0. Structured traces also improved injected fault localization from 13.0% accuracy using outcomes alone to 64.8%. But adaptation on terminal bench solved 53 of 87 tasks versus 51 for matched retrying, a non-significant difference. So persistence looks promising when tasks share procedures, but it is not automatically better than trying again.
A related trace study converts agent behavior into compact, finite state machines. Across 12 datasets, these models used 7 to 43 states and replayed held-out traces with at least 0.997 fitness. Failure prediction quality varied more widely, with area under the receiver operating curve from 0.703 to 0.941. Editorially, these state and transition features could help a repair system target patches, but no such integration was reported. A clean experiment would compare raw traces, structured memories, and automaton-derived features under the same rollout budget.
Coordination was the second major agent theme. Agent Room lets coding agents edit a shared conflict-free workspace while declaring claims and status. In one matched TypeScript setting, quality was 0.669 versus 0.456 for parallel merging, and one file abandonment fell sharply compared with solo runs. Mars instead routes a program sequentially through algorithm specialists and reached 0.624 on 165 competitive programming tasks, about 14.4 points above direct prompting. These results support coordination in their tested settings, not a universal advantage. Compute was not comprehensively matched, and stronger, search-heavy coding systems still led Mars.
The mathematical multi-agent system is even more tentative. Its authors report novel constructions or bounds on 5 of 12 problems, with multiple agents involved in 19 of 28 highlighted findings. Those are author-verified claims, not independently confirmed discoveries, and there is no matched single-agent control. Across all 3 coordination papers, the decisive next study is straightforward. Equalize tokens, tool calls, and wall time across concurrent teams, sequential specialists, heterogeneous groups, homogeneous groups, and independent sampling. Then judge code with hidden tests and mathematics with blinded expert review.
Robot control produced a concrete conceptual pairing. GigaBrain conditions actions on explicit predicted subgoal images and progress values. On gift wrapping, success moved from 0 in the base condition to 80% when both signals were present. But typical real robot cells used only 10 to 20 trials, and part of the source is missing. Lawa compresses future change into latent intentions rather than generating future video during deployment. With 10% of RoboCasa data, it reported 65.6% success, and 338.5 milliseconds per action chunk.
Those robot numbers come from different protocols, so they are not a head-to-head ranking. Together they motivate a better question. When does predicted future information help, and when does an incorrect prediction mislead the controller? Researchers should inject calibrated corruption into sub-goal images, progress estimates, and latent intentions on matched tasks, then measure task success, recovery, calibration, and latency. Lawa's real-world evidence spans one robot and 4 tasks, while GigaBrain's scaling factors are not cleanly isolated. The measured evidence supports feasibility, not broad robotic generality.
Dense on-policy supervision appeared across video, image generation, security, and math. ORARL treats annotations as Oracle rollouts but keeps them outside the policy's normalized advantage baseline. Naively mixing the Oracle lowered a 3-task average from 60.3 to 55.4. The decoupled method reached 62.7 and reduced advantage inversion among retained rollouts to 0.3%. In diffusion generation, a reward gradient method led 19 of 20 held-out reward-specific comparisons. Yet one diagnostic showed that a better constructed target could produce a worse immediate optimizer update, separating supervision quality from optimization quality.
Security shows why method labels alone are insufficient. SecOPD uses a clean context teacher to score tokens generated from attacked inputs. Against one adaptive attack setting, attack success fell to 9.0%, compared with 94.0% for MetaSec-Align. But on Agent Dojo, GRPO had lower attack success, 0.7 versus 4.7%, while SecOPD preserved more benign utility. Another study showed that endpoint authorization could reduce forbidden actions from 85.2% to 0, even while upstream artifact preservation remained only 4.7%. That is strong evidence for defense in depth, not proof that prompt injection is solved.
Verified execution also powered cybersecurity training. OpenAegis reached 58.1% on CyberGym under a 1-hour budget, versus 29.6% for its base model. Context compaction at a 90% threshold also beat full history and truncation variants. Still, the pipeline's contributions were bundled, training used substantial compute, and patching plus security question answering received less rigorous evaluation. The open question is which gain comes from executable environments, skill guidance, successful trajectory filtering, data mixture, or context management. Component ablation should hold the backbone and trajectory count fixed.
On multimodal scale, WMM's 9 billion parameter embedding model scored 80.6 on one broad benchmark, narrowly above the strongest listed comparison at 80.2. Its compact 256-dimensional representation retained 98.7% of the larger image and video subset performance. Separately, Lion BVD reports 80 million videos totaling 10 million hours. The best controlled scale result was much smaller than the headline size suggests. At equal samples seen, greater video diversity added 0.58 aggregate points, with an interval from 0.40 to 0.76. Licensing, safety, bias, caption quality, and private deployment evidence remain incompletely audited.
Several smaller findings deserve attention. Adaptive canvas length improved English to Chinese masked diffusion translation, though German evidence was weaker. Torchmorph reported large operator-level speedups over CPU references, not competing GPU libraries. And MEMUs found that direct memory question accuracy rose from 19.7 to 70.1% across capacity conditions, while satisfaction differences stayed below 0.06 within user standard deviations. Remembering facts better did not measurably make users happier. That negative result argues for evaluating whether memory is naturally and appropriately integrated, not merely retrievable.
The concise takeaway is that today's strongest pattern is moving intelligence outside static model weights. into verified state, repairable harnesses, coordinated workspaces, predictive control signals, and executable feedback. The promising gains are real within their reported tests, but narrow trials, missing uncertainty, private assets, unequal compute, judge dependence, and a partial collection limit generalization. Priority experiments should corrupt supervision, match compute, isolate persistence mechanisms, test unseen attacks, and validate real deployment metrics prospectively. For paper-by-paper results, caveats, and source links, consult the linked daily summary.